Today we're talking about horizontal and vertical translations. So we are shifting our parent functions horizontally and vertically. So if we look at number, let's look at number 2. Okay, here we have an absolute value function. So our parent function is going to be absolute value, and the equation y equals absolute value of x. We are shifting opposite. Since we're inside the house with our x, we're shifting opposite of what our x tells us to do. So this will be a horizontal shift to the right one. So our vertex, instead of being at 0, 0 where the original parent function is, we are now shifting our new vertex to the right 1 unit. So if you look at the original parent function, if you look at your foldable, from that vertex, every unit goes up and to the right 1 unit, and also up and to the left 1 unit. And our absolute value function has now been shifted 1 unit to the right. So our new vertex, instead of being at 0, 0 where the parent function is shifted 1 unit to the right. So we are now at 1, 0. The domain, if you look here, still goes from negative infinity to positive infinity, left and right. And the range, still the lowest we are is 0, and the highest we go is all the way up to infinity. 0 to infinity. Infinity always gets parentheses, and since it's touching 0, 0 gets a bracket. All right, flip it over to the back page. Now let's do a couple different translations. So if we look at like number 7, okay, 7, we have a cube root function, and the parent function for cube root is y equals cube root of x. Okay, well, our cube root is going to shift, since we have a negative 1 inside the house with the x, that's going to shift us to the right 1 space. And the minus 5 is independent. He's out here at the end, so he is going to shift us down 5. So our vertex is going to shift right 1 and down 5. There's our new vertex. So the vertex there is going to be at 1, negative 5. All right, from there, we will now continue to plot our original parent function coordinates. The parent function, if you have your yellow foldable, the vertex starts on 0, 0, and that first coordinate is over right 1, up 1. So from this new vertex, we're going to go right 1, up 1. The parent function has another coordinate that goes left 1, down 1. So from this vertex, we're also going to go left 1, down 1. The parent function has a coordinate that goes right 8 and up 2. So from this vertex, we are going to go right 8 and up 2. The parent function also has a coordinate that goes left 8, down 2. So from this vertex, we are also going to go left 8 and down 2. 1, 2, 3, 4, 5, 6, 7, 8, down 2. And then we're going to connect our dots here, and there is our cube root function. So domain, left to right on the x values, we go from negative infinity all the way to positive infinity. Now the range, the lowest this thing goes, well, he goes down and to the left forever. So he's going to go down forever. And this guy over here is going to go up and to the right, so he's going up forever. So we are going negative infinity to positive infinity there as well. Number 8, with a rational function. I want to put this denominator in parentheses. So this parent function is rational. The equation for the parent function for rational is y equals 1 over x. All right, we are obviously shifting here with rational. We are shifting our asymptotes. Okay, so when it says plus 1 inside here with our x, we're always going to go the opposite of what our x tells us to do. So we're going to go left 1, and the minus 3 at the end tells us to go down 3. So my asymptote, instead of being on 0, 0, is going to shift left 1. There's my new asymptote. And we're also going to go down 3. So 1, 2, 3. Down 3 is going to be my new horizontal asymptote. So my new asymptote got shifted left 1 and down 3. So we're going to call that as our vertex. Okay, we shifted left 1, down 3. So there's the intersection of our new asymptotes. All right, so if you look at your original parent function here, from that intersection of your asymptotes, you have a coordinate that goes left 1 and down 1. You have a coordinate that goes left a half and down 2. And you have a coordinate that goes left 2 and down a half. So we connect those 3 dots, and it gets closer to the asymptote but never touches. All right, you also have 3 coordinates from your original parent function. One goes right 1, up 1. One goes right a half, up 2. And one goes right 2, up a half. So then we will connect those 3 dots, and they get closer to the asymptote but never touches the asymptote. So the domain here, going from left to right, we go from negative infinity, and this one works its way to the right. It does not cross over this asymptote. There's an invisible wall here. The asymptote is on negative 1. So it goes from negative infinity to the left, and negative 1 is the farthest to the right it can go. It does not touch the negative 1 because it's asymptote, so he gets parentheses. But wait, there's more. There's another section of graph here. This one starts at the negative 1. That's as far left as he goes. He does not go any further left than that. He starts at the negative 1, and how far right does he go? All the way to infinity. Infinity always gets parentheses, and the negative 1 it doesn't touch. So the negative 1 gets parentheses as well. The range y values, we start from the bottom. All right, so this guy is negative infinity, and as we work our way up, he does not cross over this asymptote. So he gets closer and closer and closer to the negative 3 right here on the y, but he can't cross it. So he goes negative infinity to negative 3. Again, it doesn't touch the negative 3, so he gets parentheses. But wait, there's more. Then this section here, he starts at the negative 3. He doesn't go any lower than that. So he starts at the negative 3, and he goes all the way up to infinity. Negative 3 to infinity. Infinity gets parentheses, and the negative 3, it doesn't touch that asymptote at negative 3, so he's got to have a parenthesis. All right, flip it over to the back. When we are when they give us our word problems, if you will, basically giving us a description of the transformations, we have to write the equation. So if you look at 10, if I need an absolute value equation, I'm going to say y equals, or you could use f of x equals. Either way, I prefer to use y equals. Absolute value, I know it's going to have these absolute value bars. I know I need an x inside the bars, and this says a horizontal translation to the right 3. So that's going to be inside the bars. The horizontal translation is the one inside the house with the x. Well, if it says to the right 3, I always got to go the opposite. So I got to go minus 3. And now the vertical translation down, that's going to go at the end. Well, down 5 means we need a minus 5. The only one that's the opposite is the one inside the house with the x there. If you look at 14, our rational function, horizontal well, first of all, rational function, y equals, I should know what the parent function looks like, 1 over x. Well, in this case, it's going to be 1 over horizontal translation to the left 5. So down here with my x, if I go left 5, I got to go opposite. So I actually need a plus 5 right there with my x. And then a vertical translation down 3 units. So that's going to go at the end, minus 3. If you look at 16, 16 gives me a vertex, and I need to come up with the equation. It's a quadratic function, so I know I need to have y equals. I know I need to have some sort of x squared, but since I'm going to have a shift, the squared is going to go on the outside. So if this says I'm shifting negative 5 on the x-axis, well, what do I need inside here? The opposite of that, so I need positive 5 to go inside here. If I'm going negative 2 for a vertex on the y-axis, then that means I shifted down 2. So my minus 2 is going to go on the end. So we should be able to go from given a vertex writing the equation, or if given the equation, we should be able to figure out our vertex.